Sri Gurubhyo Namaha, children. Welcome back to our online learning initiative Ekalaiva. In our previous class, we learned that about electricity, uses of electricity. We have learned what is charge, what is electric current, what is potential difference, units, formulas. Yes, and we also discussed about the differentiation between the ammeter and the voltmeter. In today's class, we are going to learn about the relationship between the potential difference and the current. This relationship we used to call it as Ohm's law. So today's topic is Ohm's law. Let's go to the topic. In the year 1827, George Simon Ohm, a German physicist, derived a relationship between the electric current and the potential difference. As I said earlier, this relationship we used to call it as Ohm's law. Now let us state Ohm's law. The current flowing through the conductor is directly proportional to the potential difference applied across its ends, provided the temperature and other physical conditions remain unchanged. So Ohm's law states that potential difference is directly proportional to the current, that is V is directly proportional to the I. Let us derive a formula. As Ohm's law states that V is directly proportional to I, we know very well that whenever there is a proportionality, in order to remove that, we used to bring a constant. So this V is directly proportional to I will become V is equal to R into I. So this R is constant here, and R stands for resistance. So what is resistance? Resistance is a property of a conductor which will resist the flow of electric charge through it. The SI unit of resistance is ohm, and it will be represented with the Greek letter omega. So this R will become V divided by I. So resistance is nothing but is the ratio between the potential difference and the current. So we can otherwise write it as V is equal to I into R, or otherwise I is equal to V by R. So in order to remember these formulas, let me give you a Ohm's law triangle which will help you to memorize the formulas very easy. So here R is equal to V divided by I, and I is equal to V divided by R, then V is equal to I into R. Yes. So now we are going to do an activity in order to verify this Ohm's law. So the aim of the activity is to study the dependence of V across a resistor on the current I passing through it, and we are going to determine the resistance, and we are also going to plot a graph between V and I. Now let me tell you the materials required for this activity to do. We need a battery eliminator. A battery eliminator is an instrument which is going to maintain the potential difference in this circuit. And we need ammeter. Ammeter is a device which is used to measure the current flowing through the circuit. And we need voltmeter. Voltmeter is a device which is used to measure the potential difference across the ends of the conductor. And we need rheostat. Rheostat is an instrument which is used to regulate the amount of current flowing through the circuit without changing the potential difference. And we have sliding contact in rheostat. This sliding contact will move horizontally from this corner to that corner. By placing 5 different places, we are going to measure the current and as well as the potential difference. And we need plug key, and plug key is going to act like a switch. By using that, we are going to open and close the circuit. And we need a resistor. A resistor is a component which opposes the flow of electric charges or electric current. Okay, so we are going to find out the resistance of this resistor. Let me tell you the connections. In all the apparatus, we can observe two knobs, one in black color and one in red color. Black color indicates the negative terminal and red color indicates the positive terminal. So, positive terminal of the battery will be connected with the positive terminal of the ammeter. Then the negative terminal of the ammeter will be connected with the one terminal of the resistor, and the other terminal of the resistor will be connected with the one terminal of the rheostat. Then the upper terminal of the rheostat will be connected with the one end of the plug key, and the other end of the plug key will be connected with the negative terminal of the battery. And voltmeter will be connected parallelly with the resistor. So once I have connected, this is how my circuit looks like. Okay, as I said earlier, by moving this rheostat in 5 different places, I'll be getting 5 different readings of ammeter and as well as 5 different readings of voltmeter. Once I took the reading, I'll be tabulated. So here is my tabulation. So I have got 5 different readings of ammeter reading and 5 different readings of voltmeter reading. So once I have tabulated, and we need to find out the resistance. So R is equal to V by I. So when I calculate the resistance of all the observation, I have got a constant value, that is 25. Then if I calculate the mean, I'll be getting the 25 ohm. So 25 ohm is the resistance offered by the resistor. So once I tabulated, I need to plot this in the graph. And before plotting it, in x-axis I should plot the ammeter reading, that is current, and in y-axis I should plot voltmeter reading, that is potential difference. So when I plot it, when I join, I'll be getting a straight line. So I have got a linear graph. So after plotting a graph, by finding out the slope, we can find out the resistance. So let me find out the slope value. The formula to find out the slope is y2 minus y1 divided by x2 minus x1. So this is my y2 and this is my y1. This is my x1 and this is my x2. So I'm going to substitute the values in the formula. Y2 is 15 and y1 is 10. So 15 minus 10 divided by 0.6 minus 0.4. 15 minus 10 is 5 and 0.6 minus 0.4 is 0.2. So when I simplify this, I got the value of 25 ohm. The slope is nothing but the resistance offered by the resistor. So 25 ohm is a constant value we have got. What are we concluding from this activity? The value of R is found to be same and constant in all 5 readings. Yes, we have got 25 ohm. It is same and constant in all 5 readings. The resistance of a resistor is ratio of potential difference V and I. So R is equal to V by I. The graph of V and I is a straight line. Yes, obviously we have got a straight line. This shows that V is directly proportional to I, and this verifies the Ohm's law. So Ohm's law states that electric current flowing through the conductor is directly proportional to the potential difference across the ends of the conductor, provided the temperature and other physical conditions remain unchanged. So hence we have verified the Ohm's law. Hope you would have understood the concept. See you all in the next class. Thank you, children.